Today's activity involved rigid transformations. Now, we were calling them transformations in class, but let's be more specific. We're going to call these rigid. The reason that they're called rigid is the fact that the original shape and then the image created by transforming it preserve something. So our first, the translation, preserves the size, shape, and orientation of the figure. So that's the rigidness of that transformation. All it's doing is sliding, okay, from one spot to the next. Okay, nothing's changing, nothing's turning, nothing's growing bigger, nothing's growing smaller. Every point is the same distance from the other point. It's just that we are translating it or sliding it. The one that we had dealt with on Friday and again this morning preserves the size and the shape, but not orientation. And we call this, of course, our reflection. Now, our reflection has an added piece that we must recognize, that it has a line of reflection. So there's no line of translation, but there's always going to be a line of reflection. And what some of us noticed today in our work, that if we map out or measure points and their distance or their length from that line, we can see that that actually helps some of us with some of those harder reflections, because those points should actually be the same length or the same distance. Another word that we use for reflection is flip. Okay, so an image has been flipped. Size and shape have been retained, so there's our rigid, but we have flipped the image. Now, our new one for today that we actually looked at when we were creating that kaleidoscope, you were actually looking at rotations of the same triangle over and over and over. You were watching it turn. So let's go back to that little experiment we did and see how it works with the activity we did today. So if this right here, this triangle here, acts as my mirror, okay, these images have all been reflected, and now we are seeing the image reflected over and over and over again, or we are watching multiple reflections over intersecting lines. So my triangle, our original blue triangle, was reflected over this line here, which was intersecting this line here. So again, we reflect. So our lines are quite close together. So the rotation is happening in a very tight-knit group, but it's the same philosophy we're looking at today. My lines aren't parallel, then my reflection is actually going to make my picture rotate. We were also looking at rotating our pictures in specific directions at specific degree measurements. We'll get better at this as time goes on, but just remember that these symbols here mean that I'm either rotating clockwise, so with the clock, or counterclockwise in the opposite direction that the clock's hands flow. Also remember this word, this phrase, center of rotation. This means that today our center of rotation was at the point 0, 0. Your center of rotation may not necessarily always have coordinates. Sometimes it might just be a specific point where my two lines are intersecting, but what that means is that every point that has been turned is the same distance from that point, no matter which one I pick. This point here is going to be the same distance as this point here. It's kind of like the same as our line of reflection. All of our points are the same distance from our line of reflection. All of our points are going to be the same distance from the center of rotation. Now, some of us were doing this today in class and some of us weren't. We have to make sure that we're using the proper prime notation. So what does it mean by prime notation? It means that if I have an original figure, original triangle here, ABC, and it's reflected or translated or rotated, it doesn't matter. But if it has been transformed somehow, its new image is labeled in this fashion with the apostrophes. Now we would call the new triangle A prime, B prime, C prime. That's where that prime notation comes from. Now we do this to show that point A and A prime, okay, are related. It's just that A prime has been transformed somehow from A. Same with B and same with C. Now in some cases we actually may have a double prime, okay, or a triple prime. Now when those number of primes or number of apostrophes that you see simply tell you that the image that you're looking at has been reflected, translated, rotated once, twice, 3 times. Okay, that's that prime indication. Another word, okay, or another indicator that prime notation gives us, it actually tells us that ABC has been mapped. Okay, now we use the word mapped because our coordinate grid is actually a map, and that's what we talk about distances and degree measurements, because that's how we usually map things out. So in this case, another proper word to say would be ABC has been mapped to A prime, B prime, C prime.